Alright, in this video we're going to talk about more of the inequalities, but we will see some examples of problems with rational inequalities. In other words, fractional expressions with inequalities. So we're going to do it very similar to the method we used with the quadratic inequality. So let's do a couple of examples. Here's one. Now your critical numbers when you have a rational inequality would be where your numerator is equal to 0 or where your expression is undefined. In other words, what number would make this denominator equal to 0? You know that the denominator of a fraction or a rational expression can never equal 0. So we could never equal negative 4 in this problem. However, negative 4 is one of our critical numbers. So let's just go ahead and fix our number line here. So what number would make 0 on the top? Well, positive 3 and negative 4 on the bottom. Now, as I said earlier, you can never equal negative 4 in this problem no matter what. So I'm going to go ahead and put an open circle on that critical number so we know we cannot equal negative 4 no matter what. So if I pick some test points here, we could use what, negative 5, possibly 0, and maybe 4. And let's see what we would get when we test those in our original rational expression. I'm doing negative 5. 3 minus negative 5, that'd be 3 plus 5. So I'd get 8 over negative 5 plus 4, which would be negative 1. So if I divide that, I know I get negative 8. So that's negative. That interval is negative altogether. 0, if I had 3 minus 0, I would get 3. 0 plus 4 is just 4. So 3/4 is positive. So we're positive in this interval. And then lastly, let's check the positive 4. 3 minus 4 would give me negative 1. And then 4 plus 4 would be 8. So that's a negative number. So that's a negative interval. So we can almost answer the question straight out now. We want to know where this rational expression is less than or equal to 0. So remember from previous lessons, if you have less than 0, that means where it's negative. It means negative. So the negative intervals are from negative infinity up to negative 4. And from 3 to positive infinity. So in this case, the interval notation would be from negative infinity to negative 4. We can't include negative 4 ever, so it gets parentheses. And then also, you can equal 3, so we're going to include that one. So union, and then 3 up to infinity. So that's the correct interval notation on this problem. Remember, we cannot equal negative 4 because negative 4 would make the denominator of your expression 0, and that is undefined. So take that into consideration when you're writing the interval notation for these inequalities. Okay, you may have trouble if perchance you're not less than or equal to 0 or greater than or equal to 0. This number on the right needs to be 0 for us to use the methods that we have been doing. So to get this one in the correct notation, I'm first going to have to move the 5 to the left. So I have 10 over 3 plus 2x minus 5. And then that is less than or equal to 0. Now, we need a common denominator. Of course, the only denominator we see is the 3 plus 2x. So I've got 10 over 3 plus 2x minus 5 times, we'll do 3 plus 2x over 3 plus 2x. So we're really multiplying by 1, but I'm just changing the way it looks a little bit. So on top, we'll have to combine stuff, but our common denominator is 3 plus 2x. So on top, let's see what we get. You get 10 minus 15, so that's negative 5. And then negative 5 times 2x would be negative 10x. So that's negative 10x let's see here, 10 minus 15 be minus 5 when you combine everything on top. So we need to see what our test points for our number line are going to be, what our critical numbers are. What number would make the numerator equal to 0? Well, if I set this equal to 0 and solve it, we add the 5, divide by negative 10, so negative 1/2 is going to be one of our critical numbers. The other one, the 3 plus 2x, if we solve that, subtract the 3, divide by 2, negative 3/2. So negative 3/2 is farther down to the left than negative 1/2. Whoops. 3/2. Okay? So those are our testing point. Those are our critical numbers on our number line. Now we have to pick some test points to plug in here. No problem. Test point, something that's less than negative 3/2 would be like negative 2. Something between negative 3/2 and negative 1/2, how about negative 1? And something bigger than negative 1/2, 0 would work. So let's plug those in here and see what we get and see if it'll work for us. If I plug in negative 2, that would give me 20. 20 minus 5 would give me 15. Over, if I plug in negative 2 down here, 3 plus negative 4, so that's negative 1, which gives me a negative number in that interval. If we do the negative 1, negative 10 times negative 1, that's 10, minus 5 would give me 5. And then on bottom, 3 plus 2 times negative 1, so 3 minus 2 would be 1. That gives me positive in that interval. And then the last interval check, we could use the test point of 0. Let's see what we get here. If I do 0, negative 10 times 0 is just 0. Minus 5 would be negative 5. And 3 plus 2 times 0 would just be 3. So we're negative in that interval as well. Now, if you look at your original problem, we know the number negative 3/2 is what would make the denominator equal to 0. So we can never equal negative 3/2 no matter what. It's open circle there. But in this case, they want to know where we are less than or equal to 0. So that means negative. So here we go. We could be equal to 0 at this number, no problem. But negative would be all of these numbers. So my interval notation would come from negative infinity up to negative 3/2, not included. And then you have a skipped area, so union, and then from negative 1/2 to infinity. So hopefully this will help.